Hello, Mr. Betts here. Let's take a look at a couple examples that use derivatives of inverse trig functions. So the first one is pretty straightforward. Generally, what's going to be tricky about these is that we're going to have to use a chain rule a lot. So you'll notice that we're taking the derivative of arc sine, but it's not the arc sine of x, it's the arc sine of x squared. So remember the derivative of arc sine is 1 over square root of 1 minus x squared. So essentially what we're doing is we're going to do the chain rule with the x squared as the baby or the inner function. So we're going to get 1 over the square root of 1 minus. Now, when I say leave the baby inside, keep the baby inside, that means that wherever the x is in this formula here is going to stay in x squared for this particular problem. So this is going to be x squared squared. And then we have to multiply by the derivative of the baby. So the derivative of the inner function, the derivative of x squared is going to be 2x. Just cleaning this up, and this is something that we could have done kind of as we went. This is going to be x to the fourth here, and that 2x that we multiplied, we can just put in the numerator, and we get that expression. In the second example here, we have the same sort of thing going on. We have a function that is the arctangent, but it has e to the y in there. So this is a little bit tricky here. This y here would actually be interpreted as f of x. So we're going to have to do the chain rule multiple times. So this is kind of an interesting one. So the derivative is going to be, remember the derivative of arctangent is 1 over 1 plus x squared. So it's going to be 1 over 1 plus, and then it's e to the y squared, which is e to the 2y. But then, sorry, that needs to be a y. We need to multiply by the derivative of the baby function. So the baby function is e to the y. The derivative of e to the y is e to the y. So I'm going to multiply by e to the y. But we have to keep in mind, though, that when we're taking the derivative of f of x, we're taking the derivative with respect to x. And we just took the derivative of a y. So that y we're going to treat as a baby function, and we're going to multiply by the derivative of y with respect to x, so dy dx. In this problem, that would be interpreted as f prime of x, so times f prime of x, we could put that in here. Now, what we would need to do at this point is we would need to get f prime by itself. This is going to be basically just an exercise in algebra. To do that, I'm going to get everything on the left side because everything has f prime in it. I can't just divide by f prime because that gets rid of the f prime and it goes away, and that's not good. So I'm going to keep the f prime on the left side minus e to the y. I'm going to take the f prime out here. So we're going to have e to the y over 1 plus e to the 2y equals 0. If we factor out the f prime here, we get 1 minus that. And then f prime of x, we divide both sides by 1 minus e to the y over 1 plus e to the 2y, and we get f prime of x equals 0 divided by anything is 0. So it turns out the derivative of this function is just 0. Last example. Given that y equals 3 inverse secant or arcsecant of x squared plus 1, find dy dx. So the derivative of arcsecant is, I'm going to write this one out because this is the little bit more complicated one. 1 over the absolute value of x times the square root of x squared minus 1. Okay, so this is going to be another one where we're using the chain rule because we have this inner function or baby function. So dy dx is equal to, we're going to have the 3, constant multiple rule says that 3 just stays. So 3 over, then we're going to have the absolute value of, instead of x, it's going to be x squared plus 1. And I do want to point out x squared plus 1 is always positive because no matter what we plug in for x, it's got to be at least 0 or bigger. So then when we add 1, it's going to be positive. But we can leave it like that. Square root of x squared. In this case, it's going to be x squared plus 1 squared minus 1. And then with the chain rule, we have to multiply by the derivative of the inner function. So we're going to multiply by the derivative of x squared plus 1, which is 2x. We don't really need to do any simplifying here. We can do some rewriting. If this were a multiple choice question on the AP test, I would expect the answer to not look like this. I would expect it to, of course, have the 6x here. Probably parentheses instead of absolute values because they're not necessary. If we expand the inside, x squared plus 1 squared would be x to the fourth plus 2x squared plus 1, and then minus 1 would be x to the fourth plus 2x squared. And then actually what we could do is we can factor out an x squared inside here, and that x squared would come out. When that comes out, though, it's going to be an absolute value. So I'm not even going to worry about that. Let's just pretend like I didn't say it. Box that. That's our answer.